In this example, we're looking for the least common multiple of 25x squared and 25y. So in order to do this, since these are both monomial expressions, no addition and subtraction involved, what we're going to do is we're going to start by looking at the number. The number we're going to treat like a regular number, the coefficient there, and we'll just find the least common multiple between 25 and 25. Since it is the same number, the least common multiple is just 25. For the variables, we'll take each separate variable that we see, each separate factor that we see there, and we'll take its highest exponent that we see in either expression. So I see an x, and the highest exponent of x I see is x squared. I also see a y. The highest exponent I see of y is y to the first, or in other words, just y. So this is the least common multiple between the two expressions. In this example, we have three expressions. We have 28b squared, 20ab to the third, and 16b to the fourth. Since they're all monomial expressions, I don't have to factor any polynomials, so we're going to start by looking at the numbers. Now, there's several ways you can find common multiples. One way involves just making a list of the multiples for each of the numbers and finding the smallest one that they have in common. Another way to do it is to look at common factors between the numbers and then also find the least common multiple of the factors that are not common. And another way of doing it is just to find the prime factorization of each number and go from there by taking the highest exponents of each prime factor that we see, which is the way I'm going to approach it here. So 28, if I try to do a factor tree here to get the prime factors, 7 and 4 is 2 and 2. So in other words, the prime factorization is 2 squared times 7. For 20, we have 5 and 4 breaks down into 2 and 2. So in other words, 2 squared times 5. And 16 breaks down into 4 and 4, which further breaks down into 2 times 2 and 2 times 2. In other words, the prime factorization is 2 to the fourth. Now, depending on the numbers, it may not be necessary to do this. For example, 2, 3, and 5, it's really easy to find the least common multiple of those ones without making this list or finding prime factors. But with bigger numbers, it becomes easier just to look at the prime factors and find the common multiple of that. So to find the common multiple from the prime factors, I take each factor I see. So I know I see 2, I see 5, and I see 7. And I take the highest power I see it in any one expression. So the highest power for 2 I see is 2 to the fourth, the highest power for 5 is 5 to the first, and the highest power of 7 is 7 to the first. 2 to the fourth is 16, and 16 times 5 is 80. 80 times 7 is 560. So our least common multiple will have 560 as the coefficient. For the variables, we're going to take each factor or each variable we see to the highest power we see it. So I see two different variables. I see A's and B's. So I'm going to just start with alphabetical order. So A, the highest power of A I see is A to the first. And for B, the highest power of B I see, if we look at the exponents, is B to the fourth. So this is our least common multiple. Okay, for this example, to find the least common multiple of 5x and x plus 3. Now here we notice that we are actually getting some longer polynomials now. Before it was just monomials. This one on the right or left is still a monomial, but x plus 3 is not. So we're going to have to try to factor these in terms of polynomials. So 5x is a monomial and can't be factored in terms of polynomials. And for the x plus 3, there is no common monomial and no exponent, which means we cannot factor it. So both of them do happen to be factored already. Now that we've taken care of that, I do want to emphasize the fact that since x plus 3 is connected by addition and there's no multiplication on with it, x plus 3 itself is an entire factor. So when I go to find the least common multiple, I'm going to take each factor I see to the highest power I see it. Here we have a numerical factor connected only by multiplication. That coefficient needs to be included in our least common multiple. There are no other coefficients, so there's nothing to try to figure out like we had to do with other numbers. It is just 5. For the expressions, I also have x as a common multiple or factor. So because x is connected by multiplication, I need to include the x there. And I see no other exponents with x, so it's just x. And I also need the x plus 3 as a factor in my common multiple. Now, one of the mistakes people commonly make with this is they say the common multiple is 5 times x plus 3, thinking that they can just add x on here, or add 3 onto the x, turning it into x plus 3. However, a common multiple needs to be able to multiply to be that common multiple. And we can't multiply x by plus 3 to turn it into x plus 3. That would be changing it through addition and not multiplication, meaning it's not a multiple of either of the expressions. Okay, in this one, now we have 2 binomials for this, for the least common multiple. So going through, we need to make sure we can't factor it first. So 2x plus 3, there's no common multiple, or sorry, no common monomial in both terms, and because there's no exponent, we can't factor it. Same thing with x minus 4. So to emphasize this again, while this 2 and x are connected by multiplication, because there's addition on the outside of that multiplication that happens after the multiplication, that means this entire expression, 2x plus 3, is one factor. Likewise, for the x minus 6, because there's no multiplication at all, x minus 6 is considered one factor. So when I go to find the least common multiple, I take each factor I see to the highest power we see it in any one expression. So the first factor I see is 2x plus 3, and the highest power I see is 2x plus 3 to the first. In other words, just 2x plus 3. And then I also see x minus 4 as a factor, and the highest power of it I see is 1, or just x minus 4. So here is my least common multiple. Okay, so we are finding the least common multiple between x squared minus 2x and x squared minus 4. As I do this, I'm going to first want to factor this because they are no longer monomials. I have to make sure to factor. So in the first one, there's a common monomial of x in both terms. So I'm going to pull x out. If I divide each term by x, I get x minus 2. And in the second expression, both terms are perfect squares, so it follows the a squared minus b squared pattern, whose factors are a plus b and a minus b. So our factors will be x plus 2 and x minus 2. So now that both expressions are changed or factored, I am ready to find my least common multiple. In order to do that, I need to take each factor I see to the highest power I see it in any one expression. So I see an x as a factor connected only by multiplication there. So x is one of my factors. The highest power I see it is x to the first. So we just have x. I see x minus 2. I see 1 here and 1 here. But since it only occurs 1 in each expression, I only need x minus 2 to the first power. One common mistake that people will do is they'll put 2 because there's 2 of them. However, it only occurs once in each expression, so we don't include it twice for the least common multiple. We take the highest power in a single expression. And then lastly, I also see an x plus 2, so I need to include that at least in my least common multiple. And there we go. This is our least common multiple. Okay, in this example, we're finding the least common multiple between x squared plus 6x plus 9 and x squared minus 9. So once again, because these are polynomials and not just monomials, they have more than just that one term, we're going to have to factor it. So the first one, I see three terms. There's no common monomial. Multiplying first and last, I have 9x squared. The combination of factors that add up to the middle term are 3 and 3. And since there's no leading coefficient, I can use the shortcut we've used. So x plus 3 squared. It's going to be the same factor twice. You can also use one of the factor patterns to get the same result. And the second one is actually a pattern as well. It's the a squared minus b squared pattern. So our factors are going to be x plus 3 and x minus 3. So both expressions are now factored, so I'm ready for my least common multiple. And when I go to find my least common multiple, I take each factor I see to the highest power I see it in any one expression. So x plus 3 is one of my factors. While I see x plus 3 in both expressions, the highest power I see in a single expression is squared. So I see it twice in a single expression. And if you do have it twice in a single expression, I recommend writing it with the exponent instead of x plus 3 and x plus 3. It just makes it a little bit more clear, a little bit easier to see what the highest power is. I also see x minus 3 in the other one, so I need to include x minus 3 as my least common multiple as well. And there we go.